Essay 4.5 Probability Basics. With today's video, we're going to discuss the basics of the probability before going into the concept more in depth. Okay, so the first thing that we're going to discuss is the key terms of this concept. So there are 1, 2, 3, 4, 5, 6 key terms that you must understand before trying any questions. Okay, number of the trials, the total number of times the experiment is repeated. The outcome means the different result possible for one trial of the experiment. Sample space means that the set of all possible outcomes in an experiment or trial. Event means set of outcomes of an experiment to which a probability is assigned. And frequency means that the number of the times that a specific outcome is observed. And the relative frequency means the frequency of the specific outcomes expressed as a fraction or percentage of the total number of the trials. So experimental probability is same as the relative frequency. Okay, then let's talk about the theoretical probability. So if a sample space has n outcomes which are equally likely to occur when experiment is performed once, then each outcome has 1 over n of the occurrence. So theoretical probability is just like in theory. It's a probability that can be identified in theory. That's what that probability means. So to calculate the theoretical probability or basic probability, we need to use this formula. So we divide the number of the outcomes in event A by the total number of outcomes. Okay, and this is also included in your formula booklet. So let's look at example number 1. So it says that a fair standard 6-sided dice is rolled and the possible outcome is identified with the variable x, and we need to find the probability of getting less than 3. So the typical a fair standard 6-sided dice is the dice that we know, the one that has the shape of the cube and has the numbers 1, 2, 6 on the side, right? So like these ones. So it actually shows on the side, but that's the dice, right? So it says that we need to find the probability of getting less than 3. So a dice has number 1, 2, 3, 4, 5, and 6. We need to find the probability of getting less than 3. So means probability of getting x value less than 3 means the number of this event getting the x value or the outcome that is less than 3 is only 2, right? 1 and 2, so it's 2. And total x value or the total number of the outcomes in this sample space is 6. So the probability of getting outcome that is less than 3 is equal to 2 over 6 or 1 over 3. So with this probability concept, what you need to remember is you always have to present your answers in lowest term as possible. Okay, then let's try example 2. So here we have to determine the probability of drawing a picture card from a single deck of the card, right? So single deck of card means a set of the card that has a 52 cards in it, and out of 52 there is 13 card that has the shape of the clubs and 13 card that has the shape of spade and the 13 card that has the shapes of the heart and another 13 that has the shape of the diamond. Okay, and out of its shape there are 10 number cards and 3 picture cards, and it is same for all the remaining shapes. Okay, so that's the reason why we have total 52 cards, And with this example number 2, we need to determine the probability of drawing a picture card, right? So first of all, since we have 3 picture cards per shape, we actually have 3 times 4, so 12 picture cards in total. And we have 52 cards in total too, right? So we can do that. We can say that if A being drawing a picture card, then probability of getting a picture card is same as 12 out of 52, because 12 is the probability or getting number of the picture card in this stack, and 50 is total number of the card. So we have 3 out of 13 chance of getting a picture card. Okay. Okay, then now let's talk about the complementary events. So 2 events are said to be complementary when one event occurs if and only if the other does not take place. So for example, it rains or it does not rain, or getting head or getting tail, right? So since we know that some of the probabilities of our outcome is in a sample space is 1 or 100%, using this information we can set these 2 formulas. Okay, so when you add an event and its complementary event is always equal to 1, or you can calculate the event if you know the complementary event. Then what you need to do is you subtract complementary event from the 1, then you can calculate your event, or vice versa. Okay, then let's try to plot or demonstrate this information visually using Venn diagram. So let's say we have an event here. Okay, so we have an event A. I'm going to say this is my event A. Then anything that's outside of this event A is considered as complementary event of event A. Okay, and we know that this is all in sample space U, right? So we know that when you have event A, anything outside of event A within the sample space is considered as complementary event, right? So we have just shown PA plus PA complementary is equal to 1 visually using Venn diagram. Then let's do example 3. So we need to find the probability of not picking a picture card J, Q, or K from a single deck of the card, right? J means Jack, Queen, or King from a single deck of card. So from the example number 2, we have calculated that drawing a picture card is 3 over 13, right? So event A means drawing a picture card from a deck, and we know that probability of drawing a picture card from a deck is equal to 3 over 13, and we are trained to now to calculate the probability of not picking a picture card, right? So what you can do is, using the formula that was shown in the formula box here, we can calculate the probability of not picking a picture card by subtracting 3 over 13 from 1. So it's 10 over 13. And 10 over 13 is probability of not picking a picture card. Then let's talk about the cases where we need to calculate the expected number of the occurrences. So if we repeat the same exact trials many times, then we might want to know how many times we can expect event A to occur in theory, right? So in those cases, we need to use expected occurrences formula EX equals to N times P, where N being number of the trials, P being probability of event. So if you look at example number 4, a pair standard 6-sided dice is rolled 78 times. We need to calculate the expected number of the 4 happening out of 78 times. Drawing 4 from a dice has a probability of 1 over 6. We know this, right? Then to calculate the expected number of the 4s, we have to do E times X equals to 4, and the number of the trials is 78 times, so 78 times probability of event of getting 4 as outcome is 1 over 6. So we multiply these two numbers together, then we get 13 as our expected number of the occurrences. Then let's try an IB question. So this is the IB question from year 2018 November paper 2 SL. So let's look at the questions. So we have in a group of 35 students. So 11 students take art class A and 13 students takes music class M, and 5 of these students do not take either classes, and 6 of these students do take both classes. One student from the group is chosen at a random. So let's start with the Venn diagram for this case. Okay, so we have total 35 students, and 11 takes art class A and 13 students takes music class M, and 6 of them takes both classes, right? Then we can say we have art, we have music. So let's say we have music here, we have art, and 11 takes art, 13 takes music, and 6 takes both, right? And we're going to have a sample space U. 5 students do not take either class. That means 5 is being here. Okay. Then we need to write down the number of the students in a group who take art class, right? So question A, we need to write down the number of the students in the group who takes art class. So we do 11 plus 6 and 17, and 17 is number of the students who take art class, right? Question B, we need to now find the probability that the student does not take the art class. So it means we have to consider the case where students only take the music class, which is the 13 students. And we also have to consider the case where students do not take either classes, so which is 5. So we have total 18 students who does not take art class. However, since we need to find the probability, we have to do 18 divided by 35, right? So probability of not taking art, right? So the answer is 18 over 35. We cannot simplify further than this, right? However, since this is the paper 2 question, you can plug in this number 18 over 35 into your GDC and find the decimal number, which is 0.514. Okay, this was the question BI. Then let's look at II. So we need to calculate the probability that the student takes either art class or music class, but not both. So we first have to calculate the number of the students who only takes art or music. So number of students who only takes art or music is same as 11 plus 13, right? 11 plus 13. So it's going to be 24. And since we need to calculate the probability of who only takes art or music, we have to do 24 divided by the total number to sample, which is 35. So we get 24 out of 35 as our probability, or using the GDC, we can also write this answer as 0.686.